Thank you, Julie. Good to have all of you with us today. Well, today we're going to be talking about spanning solutions with a timber bridge. Now, when you're talking about a bridge, that means you're talking about a crossing. And when you're talking about bridges and crossings, you've got challenges. Now, there can be a multiplicity of challenges. It could be environmental restrictions. It could be flood elevations. It could be the flow of the water, the depth of the water. You may have a wetland delineation that you're dealing with. Maybe there's a floodway or a floodplain, or maybe you've got a stream and the stream boundaries. Sometimes it's topography, where you have a lot of topography that is involved, a lot of elevation change. Sometimes there are utility easements involved. And yes, sometimes even the budget of your client may be involved as well. But don't run away, fear not. There are solutions. Now, York Bridge is a national design build timber bridge building firm. We've been around about 36 years. And in that time frame, we have built almost 8,000 timber bridges. We have these bridges all over the country. We have them in every state except South Dakota. Somehow they got overlooked. We're trying to remedy that situation. But what that means is, with that kind of a history and that kind of experience, it means we have seen almost every imaginable type of crossing. Over the years, we have developed about 5 basic crossing solutions. Today, I want to share with you those 5 spanning solutions with our timber bridges, and we'll talk about where we might utilize them and why. Okay, the first crossing solution that I want to share with you is what we call a repetitive span design. Now, what in the world does that mean? It's a little bit unusual language. Well, by repetitive span design, we simply mean you have a bridge made up of short spans that are repeated throughout the crossing. And then you have timber piling supports through the crossing that support the bridge. In other words, think like a boardwalk type of structure. The picture on top that you're seeing is a good example of this repetitive span design bridge. This is our Walsh Ranch Bridge in Fort Worth, Texas. The bridge is 136 feet long, but you can see that it is made up of 14 co-equal spans of about 9 feet 7 inches each. In this case, we're crossing over a very small stream and it's floodplain. And so we needed to get out of the floodplain, but we were able to utilize this repetitive span design to make the crossing work. The picture on the bottom is our Richmond Cove Bridge. Now, this is a 2-lane vehicular bridge in the Mount Pleasant, Charleston, South Carolina area. This is a Pulte home subdivision that's part of the Master Plan Dunes West subdivision. Now, the bridge length, it's 110 feet long, but you see the piling bench sitting underneath? It is made up of 7 repetitive spans that are about 15.5 foot long each. So that's what we mean by repetitive span design, short spans that are repeated throughout a crossing. Now, on a pedestrian bridge, normally we're using 10-foot spans. On a vehicular bridge, we are normally using 15-foot spans. Now, you might say, well, why 10 and why 15? Well, 2 reasons. Number one, those tend to be the most efficient and cost-effective for the size of the lumber involved. Especially now we're talking about the substructure, the size of the piling, the size of the timber cap on the piling, and the size of the stringers. Those are very efficient sizes that can make those spans all with dimensional sawn lumber. So it's very cost-effective and a very efficient size. But there's another reason we utilize 10 and 15-foot spans, and that has to do with the reach of our equipment. Now, this goes to construction methodology. You can see in this picture how we build our bridges. We do driven timber piling supports, and we use a vibratory hammer to drive the piling into the ground. And it's on the end of an excavator. But that means we're limited how far we can reach. You're going to see now a time-lapse video of us building our Sunset Beach Bridge, which is down in Southeast Florida. This is a 2-lane vehicular bridge. It's crossing over a wetland. But notice in building this bridge where we're working from. We're building from the deck of the bridge itself, deck level construction, top-down construction. And so because we're working from the platform of the bridge with our equipment, the reach is limited. With these size excavators, you can reach out about 15, 16 feet and drive the piling. And so it becomes a very efficient size due to the way we design and build our timber bridges. Well, where might you utilize the repetitive span design? This design works very, very well when you have a wetland, like you just saw. Maybe you've got a lake or a pond that you're crossing. The key is it's a crossing where supports are going to be allowed through the crossing. The picture that you're seeing is our Delight Quarry Bridge. It is a 2-lane vehicular bridge up in the Baltimore area. Now, this bridge is 127 feet long and it's crossing through a wetland. There is a small stream there in the middle. It's made up of these 15-foot spans, as you can see. You can also see the nice horizontal radius as well. Another example of this design is our Ave Maria University Bridge. This is down in Southeast Texas. Boardwalk, pedestrian bridge. So these are piling bents are basically 10 foot on center. Now the bridge is 182 feet long, but it's made up of these 10-foot spans. And then finally, the Iris at North Point Bridge. This is a very simple boardwalk. The bridge is 95 feet long and it's made up of 9 approximately 10-foot spans. So repetitive span design works very, very well in those type of crossings where supports through the crossing are permitted. It's the most efficient and the most cost-effective way to design and build a timber bridge. But let me suggest to you a second spanning solution. And that's what we call our short span design. Now, some spans, you don't want to put any piling in a crossing, and the crossing is very small. In that case, you're able to use just a short single span to make the crossing up. Sometimes you're not permitted, or you just simply cannot put those supports through the crossing. In those cases, we would recommend a short span. The picture on top that you're seeing is a pedestrian bridge. This is at the Four Seasons Resort Hotel here at Walt Disney World. As you can see, this is a pool complex and we're crossing over their lazy river. It's a 26-foot single short span. Obviously, you're not going to put any supports through that particular crossing. The picture on the bottom is our Park School project. This is in Baltimore, Maryland. This bridge is a 25-foot span. And you can see in both cases, we're using sawn dimensional lumber. In this case, we're crossing over a very small stream that one single short span worked for the crossing. Now, when we say short span, we're talking about spans typically of around 20 to 25 feet. There's a demarcation point that happens at 26 feet. We can span, single span with sawn dimensional lumber up to 26 feet. But once we go over 26 feet, then you have to switch to a glue laminated beam to carry the loading of the bridge. We're going to come back to that in just a moment, talk a little bit more about glue laminated beams. So we utilize these short spans with dimensional lumber. When you have a short span crossing, short stream, small canal, small wetland, and it becomes a very cost-effective method because you're using all sawn dimensional lumber. Like you see here in the picture, these are actually, I believe, the stringers from that Park School bridge you saw just a moment ago. Well, the next picture we want to show you is our Meadowlands Bridge. This is in Calabash, North Carolina. Meadowlands is a residential subdivision, and they were opening up a new section, had to carry a 2-lane road over, and they had this little stream. You can barely see the stream down at the bottom of your picture. We came up with a single short span of 26 feet to make the crossing work. The developer was looking at a culvert instead, but by using this design, it made the crossing work. We got across the stream. It worked very well. We put no supports in the stream, and it kept the cost of the bridge down to work for the budget of the client. And then finally, one other example is our recently built Dove Landing Bridge. Now, this is part of the Bishop's Landing subdivision up in Millville, Delaware. Bishop Landing is a Beazer home development. As you can see, we have a 2-lane road going through, and it was crossing over a very small stream. In this case, we recommended just a single free span design. Now, this is a 23-foot span, and you can see that sawn dimensional lumber stringer there on the side. No supports in the crossing, and it worked very, very well for both, again, the budget of the client, and they were looking for something very nice and aesthetic, and you can see the beautiful result that they ended up with over that small stream. So these short span designs work very, very well in those circumstances. The third spanning solution I want to talk to you about is what we call a free span design. Well, what if you've got a crossing that's longer than 26 feet, but you still can't put any supports in the crossing? Well, that's when you go to third design option, free span design. Now, when we say free span design, we're talking about these longer spans. The picture that you're seeing is our Bretton Woods Bridge. This is actually a 10-ton bridge that is at the Mount Washington Resort Hotel in the back going up to the ski areas. This is a 90-foot long bridge. It's a free span bridge that you're seeing here. Now, what's the difference in the short span and the free spans? To us, two things. Number one, the length. You're limited on the short spans at 26 feet because you're using the dimensional sawn lumber. And that leads us to the second point. The second difference, free spans are using glue laminated beams. Once we go over that 26 feet, we switch to use the glue laminated beams instead of the sawn dimensional lumber for our stringers. And you need to do that to be able to carry the loading. With these glue lam beams, like you see in the picture now we can make longer spans work, 80, 90, 100 feet. We can actually go over 100 feet, but realistically, the beam depth and the cost and the construction methodology becomes a little bit more difficult. So 70, 80, 90 feet work very, very well. And glue lam beams are great to build with. You're going to see coming up a time-lapse video of us building a bridge. This is the Atlantic Country Club Bridge in Northeast Florida. And here you're seeing us setting these glue laminated beams on this 55-foot long free span vehicular bridge. Glue lam beams open up a waterway. They allow us to be able to build without any type of encumbrance in that waterway. They have a natural camber to them so that they present a very beautiful side view. And we can now span longer, single span, than we can using sawn dimensional lumber. And as you can see, they give you a totally different look than the repetitive span with the trestle look with all of the piling and the supports and the cross bracing. Now you have something very clean and open looking. The cost of these bridges is higher and the depth of the beams greater. So sometimes that can be a challenge for a budget, but in certain circumstances, these type of bridges work very, very well. Well, where do you utilize a free span design? Let me suggest to you some places. Look at the picture in your top left. This is our Keystone College Bridge up in northeastern Pennsylvania. Now this bridge is 50 feet long, and you can see it's one single span using the glue laminated beams. And you can see why looking at what we're crossing. In this case, you have a very beautiful and environmentally protected, sensitive stream where they were not going to allow any supports in that stream. So the free span design worked very well. And then the picture at the bottom is our Adagio on the Greens Bridge. This is a pedestrian bridge built in Southern California. This is Mission Viejo, California, at an apartment complex. Now, what you can't really see Down at the bottom where all that vegetation is, there's a very deep gorge, very steep, very high. And down at the bottom, a small stream. So this was a very environmentally sensitive area, and they were not going to allow any supports in the crossing. So we came up with a free span design. This is 77 feet long that made this pedestrian bridge work. And there's another issue there, height. Whenever you have a steep ravine and you have a lot of height for a bridge, you don't want to be putting a lot of piling down in there. And so the free span designs work very well there. And then the picture at the top right presents another situation where you might use a free span design. This is an 80-foot free span, 2-lane vehicular bridge. By the way, this is the same project, Mount Washington Resort Hotel in New Hampshire. Mount Washington Resort Hotel is a famous landmark legacy hotel up there. This is on the entrance road going into the hotel. A culvert sat there for 50 years, and we replaced it about 8 years ago with this beautiful timber bridge. Now, you can see there's a beautiful protected stream that gets a lot of flow and debris that can come down it when there's flooding. And so again, it just made sense to use a single 80-foot free span design due to the fast-moving water that you were encountering here. So those are some of the places where we might use these free span designs. Well, let me show you a couple of more pictures here. Now, this is at Atlantic Beach Country Club Bridge. You saw them building this bridge a moment ago, 55-foot long, free span design. You see how that it's a nice and open design. This is actually a canal where no supports were going to be permitted in the crossing. The next picture is a pedestrian bridge. This is Waynesboro Greenway Trail in Waynesboro, Virginia. And we're on this trail and we're crossing an inlet coming into this river. Environmentally sensitive, no supports allowed. So we did it with a 40-foot free span design. And then finally, right here in our own backyard in the Tampa area, this is our Waterworks Park Bridge, one of two. By the way, there to the left, that's the famous Eulalie's Restaurant. If you ever come to Tampa or live around here, be sure and go eat. It's very a great place to eat there. But this is a 35-foot long free span pedestrian bridge. And what you have going on is there's a natural spring that's coming up just beyond the bridge, flows out, forms a wetland, and then dumps into the Hillsborough River. And so no supports were going to be allowed in that environmentally sensitive crossing to keep it very natural and very open. So those are the type places where we would recommend a free span design. They work very well in those cases. Well, the fourth spanning solution that I want to suggest to you is what we refer to as a multiple span design. Multiple span design. Now, what in the world do we mean by that? Well, it's a bridge that's made up of different spans of different lengths. Let me show you. Here's a couple of drawings. Look at the top one. This is a pedestrian bridge. And I'm going to show you this completed bridge in just a moment. Look in the middle over the waterway and you'll see one single span. This is 44-foot long free span with the glue laminated beams. But then look to the left, 1, 2, 3, 3 short repetitive spans. These are about 10 to 11 feet. Look to the right, same thing, 1, 2, 3, 3 short repetitive spans to make the entire 110-foot long bridge. That's what we mean by a multiple span bridge. We've got a bridge, but it's made up of spans of different lengths. Now look at the picture or the drawing at the bottom. Same thing. Now this is a vehicular bridge. The one at the top is pedestrian. Look in the middle. You have an 80-foot free span section and it's crossing a stream and utility easement. But then look to the left. 15-foot span, 15-foot span, 15-foot. Same thing to the right. 15, 15, 15. So we're using 15-foot repetitive span approaches to get to that 80-foot span. That's what we mean by a multiple span design in a vehicular bridge. Now, this is a very creative and a very interesting design solution, and it's used in a lot of different places. Well, where might you use something like that? We oftentimes use this design when you have a longer crossing and where there are limitations to putting supports through the crossing. Let me show you some examples. Look at the top. This is our Town Village Bridge in Kennesaw, Georgia. That's north of Atlanta. Some of you people in that area will know the town center at Cove, the mall there. There's a circular road that goes around the mall, and this bridge is coming right off that circular road and leading to some apartments and then connecting on through. Now, the bridge is 250 feet. Now, what's going on here? Well, you've got a floodplain. You had to get out of the floodplain, so therefore 250 foot to get out of the floodplain. But look in the middle. That's where that 80-foot free span is. Why did we do that? Well, there's a stream. They did not want or permit any supports or piling in the stream. Just to the left of the stream, you can, if you remember from the drawing a moment ago, there's an easement, a utility easement, a sewer easement. And of course, no supports were allowed in there. So to cross the stream, to cross the utility easement, we put in the 50-foot free span section, but the rest of the bridge was just part of the floodplain to get out of the floodplain and back up the banks to their elevation. And so the repetitive span approaches work very, very well. So that's what we mean by a multiple span bridge. Look at the picture on the bottom left. Here's another example of a multiple span bridge. This is our Plantation at Winyao Bay Bridge. This is in Georgetown, South Carolina. It's a residential subdivision, and this is the entrance road going in. So this is a 2-lane covered vehicular bridge that we built. Now, the bridge is 130 feet long, but you see in the middle, there is a free span section, and it's 66 feet long. You see the glulam beam, the depth of that beam there. But then look to the left. 15-foot span, 15-foot span. Look to the right, 15-foot span, 15-foot span. So we used a couple of short span, repetitive span approaches, and then the longer span in the middle. Now, why are we doing that? Well, you may think this is a pond. It kind of looks like a pond. It's not. This was classified as a wetland. There's a stream coming in, widens out, and then continues on down. But what had happened here in this residential development, the developer had used up all of his allowable environmental and wetland impacts. He only had a few left. And so we had to calculate the impact of our piling to figure out exactly how many piling we're allowed to use to get to his maximum impact limit. And therefore we put in the free span design to avoid putting any more piling that would have put him over his permit restrictions. Look at the picture on the right. This is our Hampton Lake Bridge in South Carolina. It's a 60-foot long, 2-lane vehicular bridge, multiple span. And you can see 3 spans. In the middle, you have a 40-foot free span using your blue laminated beam, and then a 10-foot span each side. Well, what's going on here? Why use this multiple span design? A couple of things. Number one, you can see the waterway we're crossing here. It is actually connecting lakes, and they wanted boat traffic to be able to go under the bridge. So we couldn't put any obstruction in the water itself. But then why not just put in one 60-foot long free span? We could have done that. We can use glue lambs and just do a 60-foot free span. By using the multiple span, it brought the cost of the bridge down, probably $40,000, $50,000, and made it work well for the budget of the developer. So there you begin to see some of the areas and places where we recommend and utilize these multiple span designs. Very creative, very interesting type of designs. Now, I want to show you a couple of final pictures, and then we'll go to our last point. This is our Emery Flats Bridge in Woburn, Massachusetts. This is an apartment complex, a little pedestrian bridge. The bridge is 50 feet long, but it's made up of 3 spans. In the middle, there's a 26-foot span using sawn dimensional lumber stringers, and then a 12-foot span each side to make up the full 50 feet. Now, in this case, we're crossing a stream. You can barely see the stream down the bottom, and it's wetland. We were allowed to put supports in the crossing as long as we didn't put anything in the waterway or in the banks. by doing the 3-span design instead of a free span design, brought the cost of the bridge down to, again, make it work for the budget of the client. The next bridge, another example of our multiple span design, is our Esplanade Lake Club Bridge. This is down in Fort Myers, Florida. Esplanade Lake Club is a residential community being built by Taylor Morrison. They had a roadway that needed to go over this canal area connecting some lakes to lead to an amenity center. When we got the drawings originally from Waldrop Engineering, they showed a conspan culvert for the crossing, but they were having issues making it work. We suggested using a multiple span design. Now the bridge is 80 feet long, but it's made up of 3 spans. You've got a 16-foot span, and then you've got a 48-foot span in the middle with a glulam beam, and then another 16-foot span on the other side. So it's that multiple span design. It made the crossing work so that connecting these lakes, they still would allow for boat traffic without any encumbrance through the waterway. And by doing it in 3 spans, again, it brought the cost down to make it work for the budget of the client. And then they were able to utilize some upgraded design in the handrail and the finishes to end up with a beautiful aesthetic product. Well, finally, here's one final example of this multiple span design. This is our Tarpon Point Bridge down in Fort Myers area. This is at the Westin Hotel and Conference Center there. And you saw the drawing of this bridge a little bit earlier. 110-foot long bridge, 44-foot free span in the middle, and then you got 3 repetitive span approaches each side. Now what's going on here? This is a sensitive canal because there are mangroves. This is a mangrove area, very environmentally sensitive. So they were concerned about putting a lot of piling through that crossing. And something else you don't see, you had some very bad soil conditions. The soils were super soft there in the canal. We had been driving piling 200 feet deep and maybe not found a bottom. And so it became a better solution from all those standpoints. Well, let's just span the canal, avoid all those issues. But then once we're past the canal, then we're coming back up the banks, those issues no longer applied. We were able to put in the repetitive span approaches. So again, the multiple span design worked very, very well in that circumstance. Well, one final spanning solution with a timber bridge, and that's our multiple long span design. Now, this is a variation of what we've just been talking about, the multiple span. It's a variation of it, and I'll show you the difference. At the top is that town village bridge we've been looking at, 1 free span in the middle, repetitive span approaches. That's the standard multiple span design. The one at the bottom is the multiple long span. It is a bridge that is 170 feet long, but it's made up of only 3 free spans using the glue laminated beams. So that's what we mean by multiple long span design. Now I want to focus in a little bit on that bridge on the bottom. This is it's a very interesting case study of how this bridge developed. Here you're seeing the drawings, both profile and plan view. The bridge was very tall. The bridge was crossing over a creek and its floodplain, and also a utility easement. When we got the drawings and opened them up, the civil engineers had thrown in a bunch of culverts, but the culverts were going to raise the flood elevation 13 feet, never ever going to be permitted. Plus the cost was going to be over $900,000, and the client wasn't very happy about that. We analyzed the crossings, the information, and we suggested, let's do a 3 span or a multiple long span design. To make up the 117 feet, you've got 3 spans of about 35 to 40 feet long. And you see those piling bents there at the top, the 2 in the crossing. Now look at the bottom. Notice these piling bents are skewed, and that's because we're trying to match the flow of the creek and also because of the angle of the utility easement. Go back to the top picture. There you can see the creek. We had to span the creek with no supports in it. And then right beside the creek is that utility easement. We couldn't touch it, but there was just enough room between the bank of the creek and the easement to be able to drop in that piling bent as long as it was skewed. And so it made the crossing work very effectively, especially because we were dealing with such a high type of a crossing. So when it all was said and done, you ended up with this beautiful timber bridge that you see in this picture coming up. The finished product, 2-lane, the vehicular bridge, again, is almost 40 feet high. You see the piling bench, you see the stream. There in the middle is a utility easement that you don't see, and it made the crossing work. And it actually came in at about $700,000 total out the door, which worked well for the budget of the client. And so those are some of the cases where you're going to see these type of bridges where you have a limited amount of piling you can put in a crossing, the height of a bridge. It could be soil conditions. You may have bad soft soils where you don't want to put a lot of piling, or it could be just the opposite. You may have rock. And when you've got rock, you're talking about a lot of drilling, again, a lot of extra cost. So you want to avoid a lot of piling in those crossings. And sometimes it's even an aesthetic situation where people just like the openness and the look of the glue laminated beams. And this is where oftentimes budget comes into play, because these can be a very cost-effective solution, less than a single long free span design. Well, let me show you a couple more pictures. This is our River Light subdivision in Wilmington, North Carolina. This is a Newland master plan residential community. And we built a lot of boardwalk out there. And we even built a pier out into the Cape Fear River that had a little covered gazebo on the end of it, or dock. And all those bridges were built repetitive span, 10 foot on center. But this bridge, notice it's a different design structurally. It's the multiple long span design. Now the bridge is 120 feet long, pedestrian bridge, but it's made up of 3 40-foot spans. Well, why? Why did we do that? You have a lot of lakes that are interconnected, and this connection was used by kayakers. And so they wanted to keep the waterway open to allow the kayakers to be able to go under the bridge. And you can see the beautiful result and the beautiful arch and camber that the bridge ended up with. And then one final example, this is Uptown Village. It's a shopping center in Cedar Hill. That's the Dallas, Texas area. Actually, this now is called Hillside Village Shopping Center. It's at a mall there. Well, look what's going on here. It's a road overpass bridge. And you can see you've got a road going into the backside of this shopping center. And so we needed to put in a span over the road and not impede the cars. So there's a 50-foot free span over the road, but then there are 2 20-foot approaches, one on each side. And that got us up to grade where the sidewalk was. So you had overall a 90-foot long bridge made up of these long multiple spans, and it worked very, very well for those crossings. Well, there you have it, your 5 spanning solutions with a timber bridge. Now, you've seen a lot of beautiful timber bridges today. You've seen a lot of different type of crossings today and how we were able to make those crossings work. Yes, there are lots of challenges that go into a bridge and into solving a crossing, but you can see how that we're able to find a solution with one of our spanning solutions. So whatever crossing that you may be dealing with, we'd be more than happy to look at it and see how we could recommend a design for you. And then you know what? You're going to end up with a beautiful legacy York timber bridge for your development.
Thank you so much, Titus.